What's going on, family? Y'all beautiful. I know y'all beautiful. We got a very special guest here today and another math problem that we're going to go over.
It's the return of the Sarah.
Sarah Silvestro back again for her second tour on duty.
She must have loved this video.
Right now, in the comments down below, give her a round of applause, guys. Alright, so today we're going to be talking about something that looks complicated because I have 4 pieces of paper and they're all blank. And no, I'm not getting lazy. Don't call me lazy. But we're going to talk about the Central Limit Theorem. Now, this takes a lot of steps, so we're going to break this down step by step. So let's say, I don't know, we have some distribution and it looks like this. 1 is all the way up there, 2 is down here, 3 is up here, and 4 is pretty much non-existent. But we're still going to graph them. So in the Central Limit Theorem, I can take samples from this data here, and let's just say I'm going to take samples of, since there's a low amount, I'm going to take samples of a sample size of 4. Alright, now typically in the Central Limit Theorem, it doesn't work unless you have 30 or more, but that would take way too long right here, right now. So I'm going to demonstrate it with 4 the best I can. But here we get, so let's say my first sample, we're going to call this X subscript 1, goes, I'm going to pick numbers randomly here, 4, 2, 1, 1. And I would find the mean of this, which would end up being 4 plus 2 plus 1 plus 1, divide that by 4. Oops, sorry guys, messed that up. Divide that by 4, we get an answer of 2 as the mean, or I should say mu equals 2, or the mu of x1. You'll see that written. That's just the mu of your sample, or the mean of your sample. We're going to take another sample. Here we're going to go 1, 3, 1, 2. We're going to take the mean of sample number 2, which is going to be 1 plus 3 plus 1 plus 2. Divide that by 4 is 1.75. Another sample. 3, 3, 4, 2. Don't know, just making up numbers. Just coming up with stuff. Equal 3 plus 3 plus 4 plus 2. 4, 3. Comes out to be a mean of 3. And what? Shaky camera, that's fine. So we're gonna keep doing that, infinite amounts of times here. It's just, but eventually we're gonna come down here. We're gonna graph this on a distribution chart here, and we're gonna actually take the mean of 1, 2, 3, and 4. It's 2.5, so 2.5 would be the center point here as a starting point. We're just gonna go by 0.5s, I guess. Doesn't really matter what you go by here. It will later on when we get further into this theorem, but right now we're just getting a basic overview, so right now it doesn't really affect us too much. And 1.0. And now I'm just going to graph what I have. 2, I have a 2 there. 1.75 is around here. 3 is all the way out here. Let's say I roll all these different 2.5s. And eventually, over time, my graph would start to fill up. Yeah, this is really sloppy. Don't try and copy my artwork. That's not a very good idea.
Okay.
As the camera goes AWire, I'm trying to describe what I'm doing at every given second because I have a really bad cameraman right now.
Oh, I'm sorry.
Just kidding, just messing around with you. That's what the point of the show is. We're sarcastic here, guys. We're very sarcastic. But anyway, eventually this would start to fill up, and eventually I'd be able to create one of those, which we defined earlier as being the standard normal distribution. Dun 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 dun. Bam, and from here I could do basically any of those previous videos that we showed you. So that's going to be part 1 of this. We're going to have a second part of this. So until next time, that's it, guys. We'll see you next time.
Sorry for the camera problems.